Electrostatic voltmeters. In electrostatic field, the attractive force between the electrodes and of a parallel plate capacitor is given by this expression given below. So we have this electrostatic voltage voltmeter which also measures the AC voltages. So the schematic diagram of electrostatic voltmeters is shown on the right hand side. So when one of the electrodes is free to move, the force on the plate can be measured by controlling it by a spring or balancing it with counterweight. For high voltage measurement, a small displacement of one of the electrodes by the fraction of a millimeter or a few millimeters is usually sufficient for a voltage measurements. So here what they are doing is that they are measuring the distance or the movement of the electrostatic plates when there is a voltage that is applied, an AC voltage applied. As the force is proportional to the square of the applied voltage, the measurement can be made for AC or DC voltage. So the electrostatic voltmeter can work for both AC and DC. The electrostatic voltmeter made with a parallel plate configuration using guard rings to avoid corona and field fringing at the edges. An absolute voltmeter is made by balancing the plate with a counterweight and is calibrated in terms of small weights. Okay. Now we'll talking about peak reading AC voltmeters. Now these voltmeters read the peak value of the AC rather than the RMS value. So in some occasion the peak value of the AC waveform is important than the RMS value. When the waveform is not sinusoidal, RMS value of the voltage multiplied by root 2 is not correct. So you might say that if you multiply with root 2 with the RMS value, you can get the peak value, but it is only applicable for the sinusoidal voltages. For a non-sinusoidal voltages, such simple method will not work. So there are two types of peak, not two, there are several. So in the first two we are seeing a series capacitor peak voltmeter and a peak voltmeter with the potential divider. Now the series capacitor peak voltmeter is shown here. It is also called Chap-Frost method of peak voltage measurement. Okay, so just note these circuit and the circuit connections. Okay, so one more important thing is that spark gaps for the measurement of high DC, AC and impulse voltages. There are peak values. So spark gaps can be measured and this measurement for the both DC, AC and impulse voltages. A uniform peak field spark gap will always have a spark over voltage with a known tolerance under constant atmospheric condition. Hence a spark gap can be used for the measurement of peak value of the voltage if the gap distance is known. A spark over voltage of 30 kV at a 1 cm spacing in air at 20 degrees at 760 torr pressure occurs for a sphere gap of any uniform field gap. But experience has shown us that these measurements are reliable only for a certain gap conditions. So these voltage measurement of these spark gaps to these spark overs at different temperature and pressure, it depends on several situations and several factors. So there are various factors that affect the spark over voltage of sphere gap are how near the earth object is, the atmospheric condition and humidity, irradiations and polarity and rise time of the voltage waveform. So all these factors affect the spark gap voltage measurement. Next we'll talk about potential dividers for impulse voltage measurement. So previously we have seen potential dividers for AC and DC. Now you are using potential dividers for impulse voltage. The schematic diagram is shown on the right. The potential or voltage divider for a high voltage impulse measurement, that is high frequency AC measurement, or for fast rising transient voltage measurement, are usually either resistive or capacitive or mixed. The following elements may mainly constitute the different errors in the measurements: the residual inductance of the elements, the stray capacitance, that is due to occurring between the elements from sections and terminals of the element to ground, and from a high voltage lead to the elements or sections. The impedance errors due to the connection between the dividers and the test objects and the ground return leads and extraneous currents in ground leads. And the parasitic oscillation due to a lead and the cable inductance and capacitance of high voltage terminal to ground. So all these factors depend and contribute to the different errors in the measurements. So the potential dividers of impulse voltage measurements can be seen here. This type is called the resistance potential divider for very low impulse voltage and fast rising pulses. So this is the setup. So you can see on the right hand side the schematic diagram where the voltage is divided by R1 and R2 connected with an impedance Z0. Okay. So the attenuation factor of the divider of the voltage ratio is given by a small a, that is nothing but V1 by V2, that is given by 1 plus R1 by R2. So for the high frequency and impulse voltages, the V1 by V2 it becomes equal to 1 by R1 plus R1 by R2 by 1 plus JR2 Cm. Okay, so since we have when we have a high frequency impulse, so this omega comes into play. So there are other ways of potential dividers for impulse voltage. One is the potential divisor using high voltage impulse measurement. So this is the schematic diagram. The other is the capacitance voltage dividers. As for the resistance dividers, we have a capacitance voltage dividers. So, okay. We can also have a pure capacitance divider with the voltage ratio divider given as follows. And then we have a field controlled voltage divider. The schematic diagram is given below. Potential divider for impulse voltage measurements also has other couple of types, that is mixed RC potential dividers, where we have both R and C as the potential division, and the RC potential dividers with 2 megavolt rating and above. So for a 2 megavolt rating and above, we have a different set of RC potential dividers. Now for the peak reading voltmeter, we have seen potential dividers for impulse voltage measurement. Now we will talk about the peak reading voltmeters for impulse voltages. So this is the schematic diagram. Sometimes it is enough to, if the peak of the impulse voltage wave is measured, its wave shape might already be known or fixed by a source itself. This highly useful routine impulse testing work. The methods are similar to those employed in the AC voltage crest value measurement. So this is the AC voltage peak value voltmeters for impulse voltages. So this is the end of this lecture. Thank you.